Usually when you check the dashboard of your car and the fuel gauge says full, there's this expectation of, like, absolute certainty.
Right.
You have gas. You can drive. It's binary.
Exactly. It's a comforting metric. I mean, we like complex systems to be visible, to be strictly categorized into, functional or empty, so we know exactly where we stand.
Right. But imagine you're driving down the highway and the engine just starts sputtering. The car slows down. The transmission feels incredibly sluggish. You look at the gauge and it still says full.
Right.
So you take it to the mechanic. They tap the glass on the dashboard. And they say, well, the gauge says you're fine, so the car must be fine.
Which is incredibly frustrating.
Exactly. And that scenario is essentially what is happening right now in the world of neurology and aging. And the dashboard we're looking at is your standard medical lab test.
Yeah, that's a really good way to frame it.
So welcome to this deep dive. Today, we're focusing our mission directly on you, the listener. We are unpacking a truly fascinating May 2026 report from Science Daily. And this is based on some groundbreaking research out of the University of California, San Francisco, that was published in the Annals of Neurology.
It's a fantastic paper.
It really is. And the core topic we're tackling today is why the current medical guidelines for quote-unquote normal vitamin B12 levels might actually be failing our brains as we age.
Yeah, it represents really the absolute definition of a diagnostic blind spot. Because in modern medicine, we're taught to just trust these standardized benchmarks.
Right.
Assuming that if a lab result falls within the normal range, we're entirely in the clear. But in this era of constant medical testing and, frankly, data overload, applying critical thinking to those exact benchmarks is totally vital.
So true.
Because the underlying science here suggests that the physiological safety net we rely on might have some fairly large holes in it.
Yeah, big holes. And just to set the foundation before we get into the actual UCSF findings, vitamin B12 is incredibly famous in the nutrition world for a reason.
Yeah.
Like, it is a foundational building block for the human body.
Oh, absolutely. Essential.
We need it to make DNA, to produce the red blood cells that carry oxygen literally everywhere, and critically for today's topic, for maintaining healthy nerve tissue. Specifically, it helps build myelin.
Right, the protective sheath.
Exactly, the sheath that insulates our nerves.
Yeah.
And without it, the nervous system simply cannot function properly. But the mission of our deep dive today isn't just to, review basic biology. We're going to explore the hidden, almost invisible gap between being technically fine on a piece of paper and being optimally healthy in reality.
We're sure two very different things.
Right. Okay, let's unpack this. How is it clinically possible that someone's lab results can come back perfectly normal, yet their brain is already showing physical signs of neurological strain?
Well, the answer lies within the specific data compiled by this UCSF research team, which was led by senior author Dr. R.E.J. Green. Okay.
So they conducted this really detailed study utilizing the Brain Aging Network for Cognitive Health. It's also known as the BRAN-CH study.
BRAN-CH, right?
Yeah. And they enrolled 231 healthy participants. Now, the demographic profile here is the first critical piece of the puzzle, right? The average age was 71.
Okay, so
And absolutely none of these individuals had dementia or even mild cognitive impairment.
wow, okay. So on the surface, this is a fully functional, totally healthy group of older adults navigating their daily lives.
Exactly. I mean, these aren't acute hospital patients showing obvious signs of distress. These are folks managing their finances, driving cars, going to the grocery store.
Right, living completely normal lives.
Right. And when Dr. Green's team analyzed their vitamin B12 levels, the numbers were striking. So the current United States minimum cutoff for vitamin B12.
Like the strict line where the medical establishment officially says you're deficient.
Yes, exactly. That line is 148 picomoles per liter. But the participants in this study, they had an average blood B12 level of 414.8 picomoles per liter. Wait, 414.8. So they aren't just barely passing the test. They're miles above the U.S. minimum cutoff.
Miles above it.
I mean, at 414.8, you get that lab report back, and your doctor probably just gives you a clean bill of health and sends you on your way.
They absolutely do. But the hidden pathology emerges when you look beyond that top-line average. The researchers actually segmented the group, and they looked closer at the individuals who were on the lower end of this widely accepted normal spectrum.
Okay, and what did they find?
Well, in those specific individuals, they found tangible, measurable cognitive deficits.
Really? Even though they were technically normal?
Yes. These participants exhibited noticeably slower thinking, slower processing speeds on standardized cognitive tests, and even delayed physical responses to visual stimuli.
Wow.
And crucially, this degradation in processing speed became even more pronounced the older the participants were.
That's wild. But looking at Dr. Green's methodology, there's a vital distinction here, right? Because they didn't just measure total B12 floating around in the body. They specifically measured quote-unquote active B12.
Yes, that's the key.
I was thinking about how to visualize this. Um, is relying on total B12 kind of like having a bank account full of foreign currency?
Yeah.
Like the money is technically sitting there in the account. Your overall balance looks huge on a screen.
Right.
But when you actually go to the grocery store to buy something, your body can't actually spend it because it's not the right currency.
What's fascinating here is how perfectly that analogy captures the biological reality of cellular metabolism.
Oh, good.
Because total B12 is exactly what it sounds like. It's a gross measure of all the vitamin B12 currently floating in your bloodstream.
Right, the whole bank balance.
Exactly. But not all of that molecule is actually accessible to your cells. The UCSF researchers specifically focused on the biologically active form of the vitamin. You see, in the body, B12 needs to bind with a specific transport protein.
Okay, what's it called?
It's called transcobalamin, and it needs that to actually be carried inside the cells. So that resulting complex is what we call active B12. This is the only fraction of the vitamin that the tissues can actively utilize to maintain the nervous system.
Wow. So the standard lab test is essentially just looking at the total bank balance and completely ignoring whether the body possesses the transport mechanism to actually spend it.
That fundamental disconnect explains exactly why older diagnostic guidelines, which rely purely on that total B12 number, might be entirely missing early functional changes in the nervous system.
Because they're just looking at the wrong thing.
Right. I mean, that minimum threshold of 148 picomoles per liter. It was originally designed decades ago to catch severe, overt diseases.
Like pernicious anemia or something.
Exactly. Dr. Green noted that previous studies defining quote-unquote healthy amounts of B12 likely missed these subtle functional manifestations because they were using a blunt instrument. You can have a high total B12, but if your active B12 is running low, your brain is simply not getting the metabolic funding it needs to operate at full speed.
And if the brain isn't getting that metabolic funding, the delay isn't just, a subjective feeling of afternoon brain fog. There's a physiological roadblock causing that delay. Which brings us to the actual structure of the brain itself.
Yeah, the physical manifestation of this delay is really striking because when the research team looked at the MRI scans of these participants, they found a clear physical warning sign to back up the cognitive tests.
And what was that?
The participants with lower active B12 had a demonstrably higher volume of white matter lesions.
And those white matter lesions are critical because white matter basically acts as the communication highways of the brain.
Right. That's a perfect way to describe it.
Yeah, these are the nerve fibers that allow completely different regions of the brain to talk to each other and coordinate complex tasks in real time.
Think of it this way. If the gray matter in your brain represents the computers doing the actual processing, the white matter is the massive bundle of fiber optic cables connecting all those computers together so they can share information.
Oh, I like that.
So a lesion is essentially an area of brain injury. It represents physical damage to the insulation around those cables.
The myelin sheath we mentioned earlier.
Exactly. And having a higher volume of these white matter lesions has historically been linked to cognitive decline, an increased risk of dementia, and a significantly higher risk of stroke.
So the cables are literally fraying, slowing down the signaling efficiency. Hence the slower processing and the delayed visual responses on those cognitive tests. The electrical signals literally just cannot travel down the biological highway as fast.
Exactly.
But let's contextualize this for the specific demographic in the UCSF study. Obviously, humans need B12 from birth, but what is the underlying biological mechanism that makes hitting our 60s and 70s such a critical vulnerability for B12 absorption?
Right. Well, the vulnerability comes down to a fundamental shift in how the digestive system operates as we age. Because getting B12 from your food into your bloodstream is a remarkably complex, multi-step process.
Oh, I'm sure.
So in the stomach lining, there are specific cells called parietal cells, and they produce a protein known as intrinsic factor.
Intrinsic factor.
Right. When you eat food containing B12, the vitamin has to bind to this intrinsic factor to survive the journey through the digestive tract and actually be absorbed in the small intestine.
Gotcha.
But as people age, stomach acid production naturally decreases, and those parietal cells often stop producing enough intrinsic factor.
Oh, so without that crucial protein handshake, the B12 from your diet just passes straight through your digestive system.
Yep, it exits the body entirely unabsorbed.
Man. And on top of that natural decline in intrinsic factor, you have modern compounding variables too. I mean, older adults are often prescribed various medications, like proton pump inhibitors for acid reflux or metformin for blood sugar management.
Oh, absolutely. And both of those incredibly common drugs can actively interfere with that already fragile B12 absorption process.
Right.
We also have to consider dietary shifts. Vitamin B12 naturally originates from animal products, meat, dairy, eggs.
Yeah.
If someone shifts to a vegetarian or vegan diet later in life, perhaps for cardiovascular health, they significantly reduce their intake.
So it becomes like a perfect physiological storm. Reduced dietary intake, meeting a digestive system that is steadily losing its ability to absorb the nutrient. And all of this is happening while the brain desperately needs that active B12 for cellular maintenance.
That's exactly right.
But, okay, let's play devil's advocate for a second. We were talking about 70-year-olds. Wait, is this brain strain just an inevitable part of getting older? Or is the B12 the actual culprit driving the damage, rather than just being an innocent bystander to the aging process?
Yeah, I mean, that is the pivotal scientific question. And it highlights exactly why this UCSF research is completely reshaping how we view neurological
Now,
aging.
so,
Well, co-first author Alexandra Boder-Richard provided a very compelling perspective on the scope of this issue. She stated that these findings suggest that low, but technically normal, B12 could have much broader effects than previously recognized.
okay.
To quote her directly, she said these levels could, quote, impact cognition to a greater extent than what we previously thought, and may affect a much larger proportion of the population than we realize.
A much larger proportion of the population.
Correct.
Wow, that really moves this from a niche nutritional issue to a massive public health consideration.
It does. Now, rigorous scientific methodology requires us to note that this specific observational study does not definitively prove a one-to-one direct causation.
Right, correlation isn't causation.
Exactly. It doesn't prove that low active B12 is the sole isolated cause of the cognitive decline.
Sure.
However, Boder-Richard emphasized that ultimately we need to invest heavily in more research about the underlying biology of B12 insufficiency, specifically because it may be a preventable cause of cognitive decline.
Preventable. That word is so powerful. It makes you think, okay, if my active B12 might be low and it's fraying my brain's fiber optic cables, I should just go to the pharmacy, buy a massive bottle of B12 supplements, and pop them every single day.
Yeah.
Problem solved, right?
Well, the broader scientific consensus suggests we actually need a significantly more nuanced approach than blanket supplementation.
Okay, here's where it gets really interesting.
Hmm.
Because looking beyond the UCSF study, the wider context from newer scientific literature published in 2025 really complicates the picture.
It does.
Because there was a 2025 systematic review and meta-analysis of randomized clinical trials, right? And they looked at older adults who were given various B vitamin supplements,
Yep.
B6, B9, and B12.
Yes.
And the result, the analysis, which the authors rated as having high certainty of evidence, found that the supplements produce only a very small, marginal benefit in global cognitive function.
Yeah. It was certainly not the dramatic population-wide brain boost that one might assume. And to add another layer of complexity, researchers conducted a massive 2025 Mendelian randomization study.
Wait, what exactly is Mendelian randomization, for those who might not know?
Right, so to understand the weight of this, a Mendelian randomization is essentially nature's version of a randomized controlled trial. Before you're born, you randomly inherit genetic variants.
Okay, so it's looking at genetics.
Yes. This study looked at people who basically won the genetic lottery. They were genetically hardwired to naturally maintain higher total serum B12 levels over their entire lifetimes.
Oh, wow.
Yeah, and the goal was to see if that lifelong genetic exposure protected them. But the study found no clear evidence that having genetically higher total serum B12 protects the general population from psychiatric disorders or cognitive impairment.
Wait, really? So if the UCSF study is ringing the alarm bells, demonstrating that low active B12 is structurally damaging the brain's white matter highways,
Right.
why do these massive 2025 reviews say that giving people supplements or having genetically high B12 from birth doesn't provide a significant, measurable defense against cognitive decline? Are these fields of research just fundamentally contradicting each other?
If we connect this to the bigger picture, the contradiction actually completely disappears. And honestly, we arrive at the core lesson of this entire deep dive.
Okay, I'm listening.
Let's look really closely at the methodology of that 2025 Mendelian randomization study, the one that found no clear evidence of genetic protection.
Right.
That massive analysis had a critical limitation. Their data set utilized total serum B12.
Oh, they were evaluating the foreign currency bank account all over again.
Precisely. The exact same diagnostic trap. If your genetics dictate that you have high total B12 circulating in your blood, but your aging digestive system and cellular transport mechanisms still aren't converting or absorbing it into the active form using transcobalamin.
Then your brain won't see any protective benefit.
Exactly. Furthermore, regarding that meta-analysis showing only a microscopic benefit from widespread supplementation, simply raising B12 for absolutely everyone across the board isn't a magic cure-all.
Because some people already have enough.
Right. If you conduct a trial where half the participants already have perfectly optimal active B12 levels in their central nervous system, giving them more won't make their white matter function any better.
That makes total sense.
The benefit appears small on a global population-wide scale because a large portion of the population simply doesn't need it.
That makes perfect mechanical sense. It's like putting premium high-octane gas in a car that already runs perfectly fine. It doesn't make the car go twice as fast.
Right.
But if your car is sputtering because the fuel line is fundamentally clogged, fixing that specific line changes everything about how the vehicle drives.
The clinical reality is that for the specific subgroup of people who are silently deficient in active B12, targeted supplementation could be incredibly impactful.
Wow.
As the 2025 comprehensive review ultimately concluded, B12 deficiency remains a highly modifiable risk factor, especially for high-risk demographics like older adults and individuals on strict plant-based diets.
Yeah.
The urgent question highlighted by the newer evidence isn't whether B12 is essential for neurology. It definitively is.
Right.
The urgent question is whether our current blunt testing methods are blinding us to the specific individuals whose brains are already suffering structural damage despite having normal total B12 results.
So what does this all mean for you, the listener? Let's distill the practical takeaways from all of this complex neurology and digestion. First and foremost, the UCSF findings do not mean that every single older adult should just blindly start taking high-dose supplements without any targeted medical guidance.
Definitely not.
But on the flip side, the incredibly practical message is that you shouldn't let a normal lab result gaslight you into ignoring physical reality.
Yeah, exactly.
If you, or perhaps an older loved one, are experiencing subtle neurological changes, maybe a slight slowing down in memory retrieval, a noticeable dip in processing speed, or even unexplained changes in vision, and the standard blood test comes back normal, you now know that the standard test might simply be measuring the wrong currency.
Right. And for clinicians and patients alike, this research is a glaring signal that we need to look beyond the total B12 metric, particularly when actual neurological symptoms are present. We have to push for the incorporation of functional biomarkers.
Functional biomarker.
Yeah. As co-first author Ahmed Abdelhak and the rest of the team pointed out, radically revisiting the medical definition of deficiency is crucial. The medical community needs better, more sensitive ways to detect these metabolic shortfalls earlier before the irreversible physical damage to the white matter actually accumulates.
It's entirely about getting a dashboard gauge that actually measures the fuel successfully reaching the engine, not just what happens to be sloshing around in the tank.
Perfect analogy.
Which brings me to a final thought I want to leave you with, something to mull over as you go about your day. The UCSF research heavily emphasizes that the current definition of deficiency is too blunt and tragically misses early functional changes in 70-year-olds.
Right.
But looking at the timeline of how biological damage accumulates makes you wonder. If our standard medical tests are completely missing the hidden neurological strain in older adults with quote-unquote normal B12, is it possible these delicate communication highways in the brain are starting to break down decades earlier?
Oh, wow.
Could the fraying of our fiber optic cables be happening right now while we're in our 30s, 40s, or 50s, hiding quietly behind the exact same normal test results?
The trajectory of neurodegeneration is rarely sudden. It is a sobering question, and it underscores exactly why scientific inquiry into preventative health can never remain static. We must constantly question the fidelity of the tools we use to measure our own health.
Thank you so much for joining us on this deep dive. Keep questioning the dashboard, keep pushing for the full story, and as always, stay curious.